a little lesson on why carbon dioxide is heavier than air. And so what I have, I'm sharing my screen right here, I have a candle. Guys, has 3 candles inside of it here. I'm going to light all, I have 1 lit right now. I'm going to light the other 2. And then I have a little bit of vinegar. We'll pour that into the jar here. It's already producing quite a bit of carbon dioxide. We'll pour a little bit of baking soda. This is sodium bicarbonate, technical term for it. And the vinegar is acetic acid. And when the two mix together, it produces carbon dioxide, water, and sodium acetate is the byproducts of the reaction between the sodium bicarbonate and the acetic acid. And so right now, you can't really see it, obviously, but the CO2 molecule that gets made is sitting in this jar right now. And what I can do is I can pour it out and put the candles out. Because the CO2 is heavier, it pours into the glass with the candles in it and replaces the air, the oxygen, the nitrogen, and the oxygen that was there is replaced by the CO2, and the carbon and oxygen are bound together in such a way that the oxidation that's occurring at the candle can't use the CO2, and so without the oxygen, the fire is put out. So I could do that again real quick, just to kind of light it up again. This is kind of neat to see. And what I'm going to, after this, what I'm going to do is I'm going to show you the periodic table. A little bit left in my vinegar here. I'm going to show you the periodic table, and we're going to look at kind of why carbon dioxide is heavier than the air. And again, I have my little glass full of CO2, and I have my flame right here. And can't tilt it too much or it's just going to fall out. Pour it out. Out comes the CO2, and the flame is put out. You can see the smoke coming off. The flame being put out. So let me share my screen, and we are going to pull up the periodic table here. Okay, so we'll bring up the periodic table here, and you can see here where nitrogen and oxygen, you can see their atomic weights. One's 14, the other one's 16. I'm rounding down for nitrogen, rounding up for oxygen. You combine together those two atoms and you get a total weight, atomic weight of 30. And you know, the air is roughly 78% nitrogen, and oxygen is 21% oxygen in our atmosphere. So, but the combined weight between the two is around 30 atomic AMU, atomic mass units. The carbon dioxide, though, if you had to add up that molecule, okay, so it's 32 for the oxygen, is combined the two atoms together, and you have the 12, so you get a total of 44. Well, obviously, 44 AMU is a lot more mass than the 30 AMU for just the nitrogen and oxygen. So that's why the atom is heavier, or the CO2 molecule is heavier than the air that we breathe. A couple other questions that we had on the video was, or for the worksheet, was the why the Cambrian period, why there was 10 times as much CO2 in the atmosphere during the Cambrian 500 million years ago than we have today. And one of the reasons was that the plant life that exists on Earth wasn't around. It hadn't evolved at that point 500 million years ago. It was you didn't have just the tropical rainforests. You didn't have all the vegetation that exists today that you do, or then as you do now. So over time, okay, we have absorbed through photosynthesis and the creation, as you know, photosynthesis uses CO2 to create the sugars and the cellulose and the wood material that's in plants. A lot of that's been kind of buried over the last 500 million years. And so as a result, the CO2 is now kind of sequestered or put in the earth, is in the earth at this point. We're slowly releasing that by burning fossil fuels, but we're still a long way to go. We're up to about 500 parts per million of CO2 in our atmosphere versus during the Cambrian having 5,000 parts per million. Another question we had was the CO2, again, is absorbed by the plants. That's what sugar needs, is that during photosynthesis that CO2 is converted to sugar. And one of the other questions was, why is there more CO2 today than 200 years ago? Especially in the last 60, 70 years on Earth, we have been burning an incredible amount of fossil fuels. 200 years ago, we didn't have the technology to burn. We didn't have the energy demands that we have today that required so much fossil fuel to be used. And that's why the amount of fossil fuel, or the amount of carbon dioxide, has been rising so rapidly in our atmosphere over the course of the last 100 years. It's been going on for quite some time, but it's really exponentially accelerated here in the last 60, 70 years. So I hope those answered some questions for the work we did the other day and the lesson we did the other day in class. And that is all that I have for you guys today.